In this video, we're going to study another type of op-amp circuit called the non-inverting op-amp. The benefit of the inverting op-amp we've been studying so far is that the expression for its gain is relatively simple, as the ratio of the two resistors. In the non-inverting op-amp, the expression for the gain is not going to be quite as simple. However, the major benefit is that it will not flip the sign of the input. So, let's proceed. First of all, remember, at all times, I'm looking for V out is something times V in. I have all of the standard tools that I know. Ohm's law and KCL will be enough for this, with the exception that I need to use those two golden rules of the op-amp. Let's see how. Step number 1, at all times, is to label. So, I1 is going that way. Again, that's an arbitrary decision. Now, I need to decide which direction I2 is going to be going in. It doesn't really matter. However, to make KCL work nicely for me today, I'm going to assume I2 is going that way. And remember, I can label I3, but it's going to be 0. So now that we've labeled, we apply those two rules of the op-amp. Number 1 is the virtual short circuit. This means I3 equals to 0. Number 2 is the idea that V plus equals V minus. Now in the previous video, V plus and V minus were then connected to ground. In this video, V plus and V minus are connected to V in. So now that I've applied the rules of the op-amp, I'm going to go and start using Ohm's law to describe what all my currents are. I1 is going to be equal to V in over R1. I2 is going to be equal to V out minus V in over R2. And by KCL, I2 coming into the node has to equal I1 coming out of the node. So, V in over R1 is V out over R2 minus V in over R2. I'm expanding that fraction out because I really want to isolate for V out. If I go ahead and do that, what I will end up with is V out is R2 multiplied by V in over R1 plus V in over R2, which then simplifies to 1 plus R2 over R1 V in. From here, I see that my gain is 1 plus R2 over R1. It is positive, therefore it does not invert. In other words, if V in is positive, then V out is positive. It amplifies, provided that R2 and R1 are suitable. What's interesting about this particular amplifier is that it is not possible to make it attenuate. R2 and R1 are always positive, which means your gain is always greater than 1. You always have an amplification. And that is a non-inverting amplifier. In the next video, we'll look at how to deal with a multi-stage amplifier without analyzing the entire circuit again.